Hey everyone, in this video, we're going to take a look at how to build an AI photo application. And this is going to be a fun and easy project. But first, here's a quick demo. It's really simple. It's just going to be an app where you can upload a photo of yourself and have AI turn it into a professional corporate headshot or a stylized portrait. We're going to build this using Python and the Google Gemini API. The front end is going to be Next.js. And this is not a revolutionary app by any means, but it should give you a good starting point for how to build an AI photo app that then you can extend into something more complex if you wanted. All the code for this project is available on GitHub, so go ahead and clone this first if you want to follow along. The link is in the description. As for what we're going to be doing in this video, I'll be walking you through the project architecture and the code at quite a high level, because these days you can just get AI to write the code for you anyways or to explain anything that you don't understand. So we're only going to focus on what I think are the most interesting parts of the project and how it all fits together. Let's get started. First, let's take a look at the overall project architecture. Here's a very simplified project architecture diagram. Most of our important logic is going to be inside a Python FastAPI app, and we'll be using the Gemini API for the image generation functionality. In a real production environment, we should use a real database and a real storage solution, maybe a combination like PostgreSQL and S3. But in this project, we'll keep it simple and just use a SQLite 3 database, which comes built into Python. Now, I've also included a Next.js front end with the code for this project, just because I think it's useful to see the end-to-end result of running the whole thing, but I won't be covering the front end in this video. All the code for that is available in the project GitHub though, and it is pretty straightforward, so you can take a look if you want. And the reason I'm leaving out the front end, the cloud storage, and the database integration is that even though these things are important, there's also nothing about them that's really specific to this project. So I'd rather save time, leave this open-ended so you can implement your own integration. If you've cloned the project from GitHub, here's what you need to do to set it up. First, I'm going to assume you're already familiar with Python, but for this project, we're also going to use UV for package management. So make sure you have that too. If you don't have it yet, you can run this command to install it, or search up Google on how to install UV. Next, you need a Google Cloud API key to access Gemini. If you don't have one yet, you might first need to create an account on the Google Cloud console. Alternatively, I think you can also get one from Google AI Studio directly, and this might be a little bit easier because I know they've been trying to streamline this. So log into Google AI Studio, and then down in the bottom here, there should be a button that says Get API Key. So if you click that, you should be able to follow these instructions to create a new API key. Now, like most API keys, it is pay as you go, but there might be a free tier depending on which model you are using. So you can find information about this on the Gemini API pricing page. Now, in our case, image generation is quite compute heavy, so unfortunately it doesn't have a free tier. It currently costs about 30 cents per input image and 4 cents per output image. So it's quite affordable, but the prices can add up quickly if you aren't careful. So don't go generating thousands of images unless you know what you're doing. With that said, I think it's likely these prices will get cheaper over time as the models and the infrastructure become more efficient. Once you have the key, make sure you set it into your environment variable like this so that your app can pick it up. And finally, this is optional, but if you want to be able to run the front end, you'll also need Node.js and NPM, since the front end is a Next.js web app. Once you have all of these things and you've cloned the project, you can open it up in the terminal and then run UV sync. This is similar to pip install, and it will set up the virtual environment and the dependencies for the project. And then you can run the actual API server using this UV run command. And once it's running, you should be able to visit this URL where you'll be able to see the hello world message of the server and then access the API docs. You'll also find these setup instructions and all of these commands in the project README. Now let's get started going through the code and the implementation. The central part of this project is the image generation feature, so let's start there. For image generation, we'll be using Google's Nano Banana API. The best way to experiment with this is to go to Google AI Studio and then go to the playground. And in the playground, you can click image generation. And here you can choose a couple of different models. We're going to go with Nano Banana. Once you've selected that, you can try it out by just typing a prompt. For example, a dog in the park. And it takes about 10 seconds, but then you should see an image appear like this. So this is completely generated by Nano Banana. And if you wanted to get the code so that you can use this in your Python project, go to the top here where it says Get Code. And if you click that, you'll see an example code snippet of what it takes to actually generate whatever it is you've typed here. And this is one way to get the code for the project. But actually, I much prefer using the official documentation, which you will find at the Gemini API docs, for examples and best practices on how to use the API. And as you can see here, there's a lot of different things you could do with it. And you could see all the different examples here as well with the prompt and the techniques required to do that. But for our app, the use case we're after is what Google calls image editing, or text and image to image. So if we click that here, you'll see an example of how to do that in Python. And if you take a look at this code, you'll notice that we'll need to submit a prompt and an image as input. And something that I find really nice about this API is that it seems to natively understand the image format from the PIL or the Pillow library, which is really popular for image processing. And then it's just this line here that calls the API itself. This is a blocking function, and as you saw from our playground earlier, it takes about 10 seconds to generate an image. So keep that in mind because it will become important later. And here we just choose the model, which is going to be Gemini 2.5 Flash image. This is the same as Nano Banana. And the contents are just going to be an array of the prompt and then the image we've uploaded. Finally, if we scroll down, this snippet here shows us how to take the response from the API and then save it as a PNG file. So this is pretty much all we need to do the image generation in our project. Now let me show you how the code actually looks in the project. In the project itself, I've put all of the image generation logic into a file called invokeai.py. And I've wrapped it in a function called generateImageFromModel, which takes a list of image paths, strings, and also a style, a string as well, as the input to this function. I think that if you're building any kind of app on top of an API, it's a good idea to separate your own project interfaces from the API implementation detail. This will allow you to change the implementation later on with less impact to your app. Now let's take a look at this from top to bottom. There's some code here to create the Google Gemini client and set it up with the API key. We also have a simple dictionary here where we store the text prompts and the style code for each one. So you can see there's 3 different styles: corporate, black and white headshot, and a casual style. And you can see the full prompt for those styles here. And aside from those things, most of the code is pretty much the same as the example we saw from the API documentation. Of course, we also need some logic to actually load the images from the image paths and also to look up the actual prompt we're going to use from the dictionary given this style key. But other than that, we pretty much just plug it in here to this API call. So overall, as you can see, this is pretty straightforward and it is going to be the central function of our app. Now that we have the function to generate images, we need to wrap it up in an API so that we can wire it up with an interface, like our Next.js frontend. To do that, I'll be using FastAPI. If you haven't used it before, you can check out my previous video on it here. The link will be in the description. It's only 15 minutes long. We'll be splitting the app up into a few different endpoints. Here's a simplified signature of the 2 main endpoints. First, we'll need one to create a model. This will take a list of files, images that the user will upload. And a model here means basically a model of a person. So a photo of a person that we want to use in later image generations. And the second one is to generate the actual photo using an existing model. It'll take a model ID as input and a style instruction, which we'll use as input to the prompt. In the app itself, we will just run these 2 things in sequence, so the user won't even know that it's actually 2 separate operations. But the reason I've separated these 2 things is because it's more extensible. And what I mean by that is that it's probably useful for most apps to have the image upload functionality be separate to the image generation functionality. For example, you might want to give your users the ability to upload a set of images once, maybe as a profile or as a reference, and then reuse them again and again across a lot of different image generation attempts. As a bonus, it also makes testing and maintenance easier. Here's a high-level look of the code for create model. Remember, this is just for uploading the image. We're not dealing with image generation yet in this operation, but there's 3 important things we need to do here. First, we need to come up with an ID for the model. Then we need to save all of the uploaded images to storage. And then we need to save that model ID along with the image paths to the database so that we can look it up later. And the reason I've simplified this function and just kind of showed you the pseudocode with the comments is because the logic and the design here is more important than actual implementation. For example, you could use different solutions for storage or for the database. Now, if we pop over to our actual code, this is what it actually looks like. We just use a UUID4 as the ID for the model. And because we're keeping it simple, we're just saving this file to disk. So this will save it into our local disk directory of wherever we're running this API application, which in this case is just going to be in a hidden file in this folder. If we wanted to make this production ready, we can easily replace this section with cloud storage like Amazon S3, Firebase, or GCS. And this will work just fine because instead of a file path, we'll get something like an image URL that works pretty much like a file path, and we could just store that instead. Now down here for the database, I've created a DB abstraction, which we'll look at next. But all you have to know at this point is that we're going to use the model UID as the primary key and the saved image paths as the value. And this would also work just as well if you switch to cloud storage, because most storage solutions will still use some kind of string key for its image URL. And down here is the code for the generate photo endpoint. It takes a model ID and a style as the input. Again, this is pretty straightforward. We start by looking up the model ID in the database so that we can load the image paths. Then we're going to create something called a job. This will have a UUID as well, and we'll store this job and a job status into our database. We'll then start processing the image asynchronously using this background task feature from FastAPI, and then return the job ID to our user instantly so that they can look up the job whenever they want. And the reason we're doing it this way is because, as I mentioned earlier, the image generation process is a synchronous operation, and it can take up to 10 seconds to complete. That might not sound like much, but it's actually quite a big problem if we need this app to scale. And here's why. Normally, we want our operations to finish up within milliseconds, for example, 100 milliseconds or even lower. If the average latency becomes 10 seconds, that's a 100 times increase. It also means that our number of concurrent connections will also increase by 100 times. And that is a big problem for things like memory utilization and connection limits, like file handlers. It also means that if a connection is lost during that 10 seconds, which is much more likely compared to a shorter operation, then that request would fail. In other words, having operations with really long latencies in the order of seconds is a recipe for really bad compute utilization and also a really unstable service. Now, these are problems you won't really have to worry about at all if you're just learning or prototyping, but it's good to understand why it's better to implement it this way. Now, there's something else I want to show you. There's this function here called process image generation, which is the actual function that we send to our background task. It's over here in our file, and if you look at it, it's really nothing crazy. It's basically just a wrapper for our image generation code that we looked at in the previous chapter. And once the image generation function finishes, and remember, this is the synchronous part that can take up to 10 seconds, we save the results to storage, again, our local file system in this case, and then update the job in the database to say that we've completed it. And here is the output path. We can then use the job ID to look up the status of the job or to get the image itself once the job is completed. Here's the 2 additional endpoints we'll need in our app to do that. I won't go through the implementation here because it's super straightforward and the code is on GitHub if you wanted to take a closer look. Now let's talk a little bit about the database. Our database implementation is in a file called db.py. For this project, we're using Python's built-in SQLite 3 database for simplicity. It basically loads and saves the database into a file path, which we can specify like this. This allows us to get going really quickly without having to set up or download anything else. But this is the interesting part. This is the SQL query that defines the database schema. It's basically 2 tables, and you can probably guess already, one is for the models and one is for the jobs. Both have an arbitrary UUID as its primary key. This allows us to create jobs and models are basically image uploads in this case, and then update them or look for them as long as we have the key. This is pretty basic, but it's enough for our app. Our app doesn't have any user login and it doesn't have any kind of dashboard or history page. It's basically just a splash screen where you upload an image and then you can look up the results of that image. So this is all we need for that. But if we wanted to get serious with this, we'd probably also need to consider user authentication. So we'd need a key for user ID And then to enforce security, we also need some kind of row level security, so people can only see the images that they've created themselves. Then we'll probably also need a few database indexes so that we can do things like list 50 recent jobs by a particular user. All of that's out of scope for this video, but it's not that difficult to design if we know what use cases we want to support. If we wanted to upgrade the setup for production, it shouldn't be that hard either. Since the data model is quite simple, most popular database solutions should work here, including PostgreSQL, MongoDB, Firestore, or AWS DynamoDB. And then again, in the project, all of that code is in db.py. You could see it all here and look at how we query and set up the database. Now that we have everything set up, we can run the server. As I mentioned earlier, you can run the server using UV with this command. This will start up your server, which you'll be able to visit right in your browser. By default, it's on localhost port 8000. And then if you wanted to see all the endpoints, you can type /docs. Then, if you wanted to test the API locally, you can send API requests directly to the endpoint. It's a little bit tricky here since you need to do it in two parts, one to upload the image and one to generate the new photo. But here's what the command looks like if you want to try it. This should also be in the project README as well. And as you saw at the beginning, this project also includes a Next.js frontend, and it's in the project site directory if you wanted to see the code for that. So you could use this to do end-to-end testing with a user interface if you wanted as well. And the user interface will let you upload up to 3 images. So you can choose a couple here, and then you can choose the different styles and click generate photo. And this requires your backend API to be running. So make sure you run the FastAPI server first, because this front end will try to connect to that. And the way the front end works is that it uses an API client that we generate programmatically from the Open API schema from our app. And it wires it up to this visual interface so you can just click and interact with it. So you can really get a feel for how this app will work as an end-to-end product. Now, if you want to run the front end for yourself, but you're not familiar with Next.js, you should still be able to do it pretty easily by just using these commands. These instructions are also in the project README. So this was a pretty fun project for me to build. And with image generation getting better and cheaper, I think it's a good time to learn how to build apps with APIs like NanoBanana and Gemini. Also, with AI being so good at code assist and explaining things, I'm trying to find a new balance for these tutorials where we're a little bit more efficient with our time, but still manage to go deep on the right things. So please let me know if this style of video was useful for you, or if you prefer me to spend more or less time on certain technology or certain parts of the project. All right, well, I'll see you in the next one.